Welcome to the third session of a third lecture on the phase one of AI Research School. Uh, Today we want to continue talking about the introduction to Python programming language, and previously we talked about Arya talked about some commands in Python, while loop, conditionals, if statements. And today we're going to continue that and talk about for loops and functions. Before just getting started, I just wanted to mention that we have a TA session on Fridays at 5 p.m. each week. So it would be completely optional. You could just attend those Zoom meetings and ask any question you have on any project or any Python. I don't know, any Python question you have, you can ask your TAs. Otherwise, the TAs are online in Discord every day. You can ask them through Discord. And yes, that's it. Just try to be comfortable and ask whatever question you have. So without any further talking, let's just go to Arya. Arya, do you have the access to share a screen?
I think so. Let me just share my screen and yeah, I think we're good, right?
Great, yes. Thanks.
Yeah. Okay, hello everyone. Welcome back to the workshop. So as RF mentioned, I'll just do a quick review of what we did last time. Just quickly walk through the collab file that we made. So we covered Boolean expressions, the logical operations that we can perform on Boolean expressions, ands, ors, not, those sorts of things. Then we realized that we actually can control the flow of our program using the Boolean expressions that we have. So we did a couple of examples through if statements, if and else code, if, else if, or elif in Python, the way we write it. And we did a bunch more examples on that, and we went through while loops as well, which are kind of what we are going to expand on today, not while statements, but in general loops, because we also have a different type of loop that we're going to discuss today. Yeah, and so we just went through some examples here. If there are any questions on the last session, you can just type it in the chat and I can respond to that. But as of now, I'm not seeing anything. I just might wait a few seconds to see if anyone has any questions on the content of the previous session. And if not, we're going to move on to today's lecture. Hey, I think we're good. So this is an example of a while loop that we covered last time. We use whiles when we want to do something repeatedly. Now, there is a different types of loops that we can also use. They're called for loops, and that's the subject of today, and that's what we're going to do. Now, there is a difference between for loops and while loops, and the main difference is that if you remember how we separated the while statements last time, we have an initialization stage, we have a loop body, and the loop body executes a bunch of times. And usually at the end of the loop body, we have some sort of change to the data that is used in the condition. So in this example, for instance, there is an initialization stage before this while loop that is not here, but something like I equals 0 is the previous stage of this while statement. We have defined the I, we are printing the I, and then we are incrementing the I. If we don't use this increment, if we don't change the data that is used in our condition, we're going to we're going to have an infinite loop. And infinite loops is something that we're trying to avoid. It's a type of bug because, well, we get stuck, right? We don't want our program to get stuck. For loops are kind of something, they're very similar to while loops, but they are more self-contained in the sense that you you kind of don't have to do three things when you're writing your loop. So you don't have to do initialization, body, and incrementation, or changing the condition of the data of the condition that we have. Uh, in our for loops, we basically just need to write one line for all that stuff. I'm going to jump into code now to just show you some examples on this. So I have my session 3 ready. By the way, you guys can work on the same file. I'm working on multiple files, but I'm going to share these files as well. So um, you don't need to worry about if you just want to like watch the lectures, that's also fine. Um, Before I start for loops, I want to mention something else, which is the concept of lists in Python. And lists are something that we actually are going to talk about next session in more detail. But the way that Python works with loops, we have to kind of learn about lists. And at the most basic and simple thing that I can say about lists is that a list is a collection of, I'm using a text block, sorry. Should use a code block, yes. So a list is a collection of a bunch of things, right? So the way that we specify this collection is I have two brackets, and I can type in the data that I want in the list. Because it's a collection of things, I can type in as many data as I want. So I can go 1, 2, 3, 4, for example. So here we have, and notice the syntax that I'm using. So I'm using the element that I want to define, and then I'm using a comma in between the elements, so that we have each item in the list. And if we just want a simple code here, I can just print this list. And as you see, we get the result that we want, right? So lists are basically for now just a collection of things. We will further expand on this a bit, but now that we know a little bit about lists, what we can do is we can use a for loop, use a loop on this list to somehow either change the data or do some sort of processing on that. So we can show something like that here as well. So the way that we write in a for loop is we're going to type in for, and then I'm going to define a variable here. And we normally name our variables I. This is something that we also saw in while loops. And I'm going to type in, and then I'm going to type in the name of the list that I want to loop through and do something to the data. And I can put in the colon sign right after, the way that we did it in the while loop. And here I can just type in a statement of some sort. So for example, print I plus I times I. Let's do I times I. And if I just run this piece of code, I'm going to use Control Enter for run. As you remember, that's the shortcut key for running the block of code that we have in Colab. And as you can see, what happens is this I is going to basically take go through the list and take the position of one of the items in the list. So that means that the first and we can call this, we are iterating through the list using the variable I. So this I, at the first time that this loop executes, I will be equal to 1, right? And so this is the first time that the loop's running. So the first time this I is 1. The second time after the whole loop is done, I will be 2. The third time I will be 3, and the fourth time I will be 4. So if I, for example, change this 2 to 5 and rerun the code, as you see, this second element here has changed to 25, right? So the first time the print statement is going to be 1 times 1. 1 times 1 is 1, so we're going to get 1. The second time it's going to be 5 times 5, so that's going to be printed. The third time we're going to have 3 times 3. 9 is going to be printed, and the fourth time we're going to have 4 times 4, and 16 is going to be printed. Okay, so are there any questions here? Anything that I can address and clarify a bit more? We're going to learn more about lists, so that there is something that come up pretty much. I'm going to just go through the things in the list and the things that we have to learn one by one. And I want to make sure that we only learn insofar as we need for this session, because we're going to focus on it a bit more next time. But if there are no questions, you can do this on your own systems, and as always, you can send me a thumbs up so that I'll know we're in a good place and we can move on with the course. Okay, so that's a good question. This I, usually by convention in loops we use I, but this can be anything. This can be variable, something like that. But just make sure that you're using whatever you're defining in your code, right? So this is the same. So what Python does in the background, it's going to automatically initialize this variable the way that we do it. For example, here we say a equals 2. Python is going to do kind of the same thing, and it's going to set the variable equal to one element in the list at a time. So the first time the variable is going to be 1, the second time is going to be 5, and so on. Now, there is something that you might have noticed. If I want to print, I don't know, like the first 200, numbers, something like that. Well, it would be very redundant for me to just come in and type here list 2 equals 1, 2, 3, 4, 5, and so on. Like it's a very hard thing to do, and we don't want to do that because we want programs to make our lives easier, not harder, right? So there is another sort of type that Python offers that we can use to basically cover a range of numbers. And the way that we do that, I can actually write a new program for this. So if I want to, let's say, print the first 200 numbers, I can just type in for I in, and here I can use a built-in function that Python has called range, and I can give it a custom range. So if I just type in, let's type in 200 first, and let's see what happens. and I'm just going to print I here. I'm going to run this code. I'm going to get my output, and it's going to give me values. 200 is a lot. Let's just do 10 for now. It's going to give me values. If I just type in 10 here, it's going to give me values between 0 to 9. So yeah, the first item in the range would be 0, the second item would be 1, and up to the point of the last index that we have. I can put in two values here. If I put in two values, let's say 5 to 10 or 5 to 15, if I run this piece of code, as you see, we're going to get the numbers between those ranges. So it always starts from the left index, and it always ends before the right index, the second argument that we have typed in. We can do fun things with ranges. For instance, I can type in 10 and 1, something like this. And oh, I might have been sorry. Yeah, discard this. Um, oh yeah, we can do fun things with ranges. So if we give it a third argument here, for instance, the third argument here is going to give us the steps that we can take in the range. So for example, here I'm giving a range. Oh, excuse me a moment. That I was, yeah, I had to plug in my laptop. Okay, so if we give three arguments to the range function, we're going to take, the third argument is going to be used as a step. So yeah. Are there any questions here? Okay, if you don't have any questions, okay, yeah. So let's start from the beginning. The simplest one the simplest type of input that we can give to the range function is just one number. If you just give it one number, what it's going to do, it's going to um, start counting from 0. So if I just give this range 10, it's going to give me a number from 0 to the previous number that I'm having in typed in a range. So if I type in range 10, I'm going to get numbers between 0 to 9. So I'm going to get 0, 1, 2, 3, 4, 5, 6, 7, and 9. If I type in range 100, I'm going to get 0, 1, 2, 3, 4, 5 up until 97, 98, and 99. Now, if we give two arguments, to this range function, so if I give something like, let's do 4 and 10, I'm going to get the first argument is going to be the starting value of the range. So it's basically going to give me a range between 4 and 10, right? It's going to give me 4, 5, 6, 7, 8, 9. But it's always going to not use the like it's not going to include this number that I'm typing in my range, right? It's going to go up to that number. It's not going to include the number itself. And then another thing that we can do is we can also specify a step that we want. So for instance, if I want, uh, let's say a range between 4 to 20, but instead of printing or using giving I the value of 4, 5, 6, 7, I want to go 4, 6, 8, 10, something like that. Uh, we can use another value, the third value, and this would be the step value that we can take. So if I just put in 2 here, what's going to do for me, it's going to give me 4, 6, 8, 10, 12. If I put in 3 here, it's going to give me 4, 7, 3, 10, 13, 16, and 19, right? So it's basically setting the increment of the range to the value of the third argument that I'm giving. Hope that clarifies. Yeah, so if we give minus 10 here, we can get a negative, we can start from a negative value, right? So if I want to print the range minus 10 to 10, it's going to be something like this. Now, we kind of also have touched over types. Might be slightly advanced for this class, but I'm just going to mention this because it might be useful for in some case. There is a difference between a range and a list. So if I have a list from minus 10 to 10 to, let's say, if I have these items written here as a list, it's of a different type. It's not as the same type as range. So also keep that in mind. So when you're using, let's say, a range, uh, it's not the same as a list. Yeah. And this is kind of, if I want to give an example for this, this is kind of similar to having a string of 1 versus an integer of 1. They are of different types, right? So we can assume they're the same. The same applies for ranges and lists here. So range is of a different type than list. And we can convert them to each other, but they're not of the same nature. So if I have, let's do a quick example here. If we do the 0, 1, and 2 equal range of 3, which is going to give me the numbers 0, 1, and 2, this is going to be false. It's not going to be true. Despite the fact that if I use both of them in a for loop, they're going to give me the same result. This is very similar to typing does 1 equal the string of 1. This is also going to give me false, right? If you have still problems with this and then get that, it's fine. It's just something that I wanted to mention because if you go more advanced in programming, these things might become important. And it's good to have a basic idea right now so that when you actually have to learn these things, you don't struggle as much, because I remember I struggled with these things a lot, with types a lot. So I feel like there is a need to quickly introduce that in a beginner sort of tutorial as well. Anyways, we can continue if there are no questions here. So I'm going to go back through the slides and basically formalize what we've learned. So we name a variable and we loop through a list. And we can also use the range function. This is all the stuff that we did up until now. This is what we just covered. Okay, so I'm going to go back to code and cover this as well. We kind of learned about lists. I just want to go through this a bit more. So if I define another list and set the values to 2, 5, 3, 1, something like this. One of the things, one of the ways that we can access the elements of the list, and by the way, the elements of the list are each item that we define in the list. A list is an ordered collection of items. So we can access each element by accessing its index. And the way that we access any index of the list, we just type in the list that we have, and then we again put this bracket signs. And in these bracket signs, we can type in the index that we want to reach. And we start counting at 0. So this is index 0. This is index 1. This is index 2. This is index 3. So if I want to access 5 here, I'm going to type in, give me the list at index 1. And if I just print this out, I'm going to get the value of 5. If I do 0 here, I'm going to get 2. And the same will apply for basically all the other elements in the index. Another thing that you should note, we can create lists of different types. It doesn't have to be integers. So I can create a list of floats, for example, and I can print these values as well. And as you see, we're going to have the intended value that we have. And we can have lists of strings, something like this. Let's just name this list 1 to make it not use the list keyword. And we can print this as well. And another cool thing that we can do is we can actually have lists of different types. So I can have a list of 1 AA 2.3, and this is also going to work as expected. And finally, we can have lists of lists. So I can have a list, and inside that list, I can have another list, something like this. And if I print this out as well, as you see, we're going to get. So here we have list 5. I'm printing list 5 at index 2. List 5 at index 2 contains another list on its own, right? So this is what we're going to get here. And one of the things that I actually should mention about loops, we can also have the same that we have, let's say, lists of lists, or last session we saw we had nested while loops. So we had while loops that had while loops inside them. We also can have uh, we also can have nested for loops as well. So let's say we have another example here. We can have two lists here, 1, 2, 3, and then list 2, 4, 5, 6. And let's say I want to calculate the multiplication of the top list versus the bottom list. So the way that I would approach that, I can say for I in list 1, and here we're going to have I'm going to name another value j in list 2, and I want to print the value of I multiplied by j. And if I just run this, it's just going to give me those values. So this is similar to a nested while loop that we did last time. Here we're doing it with for loops. So I'm going to give you guys some time to do these last two examples. And once you feel satisfied with where you are, just give me a thumbs up in the chat. And if also you have any questions, just let me know and I'll try to answer. And if you need more examples on ranges or lists or things like that, you can also just let me know as well. Oh, that's a good question. How do we access the index of one of the lists within? So um, it's the same thing, kind of. So if you assume this entire thing is a list, again, if I want to index this entire thing, I'm going to use brackets and I'm going to put in an index right after, right? So if I print this, I'm going to get the index at that element. I'm just going to make this a slightly prettier example so that when you guys are uh, reviewing this, you have access to all this good stuff. Okay, yeah. Okay, so we're going to move on actually. So these are the things that we covered. Lists are a collection of values. They can have the same type, they can have a different type. As we saw, we defined a list with um, like integers and strings, and we define them both at the same list. We call each item in the list as an element, and we can index the list, meaning we can access the elements in an orderly way. Um, and uh, the way that the list is also indexed is that we start counting from 0 to the uh, basically last element of the list. If we have a list of size n, the last element would be n minus 1. And so that's the way that we can index the list. These are some examples of the list as we saw. I didn't do this one. So if you just put in brackets without anything inside, you're going to get an empty list. So it's just a list of size 0. Um, and this is again another example that we have. So here we did a pretty similar one here. So we have a car list. The list is of a bunch of car brands, different car brands, and we're printing uh, the items, each element of the list using a for loop here. And we talked about nested loops as well. So we can have two or more than two blocks of fors defined within an outer loop. So we have something like this. We also can combine fors and whiles and fors, anything like that, right? Also, the way that we did last time, we wrote an if statement inside a while loop. We can do the same for a for loop as well. So we can put on an if statement um, inside a while loop. We're going to move on to the next topic of the session. And so we're kind of done with fors. Uh, they will come up similar to if statements everywhere. Basically, where you're programming, you need to work with this stuff, right? So we're not fully done with them. We're definitely going to use them in the future, but we have the basics down. And I'm going to move on to the next topic now. I don't think there are any more questions in the chat. Yeah. So I'm just going to move on to the next topic. The next topic that we are going to talk about is functions. And here I'm going to talk a little bit of theory, and then we are going to go through and do some coding as well. So it's oftentimes that when we are programming, uh, we basically want to have some pieces of code um, that come up very often. So it's like if you're doing a certain mathematical equation, let's say if we um, if you know some trigonometry, there are some functions that estimate how we calculate sine and cosine and tangents and cotangents and stuff like that. So if you want to, let's say, if you want to calculate a sine value in some part of the code, but we also need to calculate a sine value of a different variable in another piece of the code, it's not a very good idea to just do a whole bunch of equations, do a whole bunch of mathematics every time that we need to calculate a sine value or something like that. So uh, the way that this is resolved in programming is through functions. So functions do a certain task. They instead of writing an entire code in just one big chunk of code, we can separate our code and modulate our code into different units, and each unit can do a certain different task. And that's the purpose of functions. So functions are basically pieces of code that are designed by the programmer to do a certain thing. Um, they usually either give a certain output to the place that they are called from, or they do a certain thing, they print something, they do some calculations, they change some data, and stuff like that. Um, and they also help the programmer and the people who are coding, because you might not just be the person who are doing the code. There might be like five other people working on that code as well. What functions do if you're doing them in the right way, if you're doing them in the proper way, they will make the code more easy to read and also more maintainable, meaning that it's easier to add code to an existing code and let's say make more functionality for the code. Um, Now, Python has some built-in functions that we can use. This is something that you don't have to memorize at all or anything like that. Uh, but these functions, they all achieve a certain thing. Some of them may come up in this course. Some of them might not. One of the functions that, let's say, we've already been using was the range function. So the range function basically gives us back a range of numbers that we can iterate through, we can print, we can do stuff with. Um, and yeah, and there are other functions that might come up. One of the things that you have to take away from this, though, is that like when you're defining your own functions, you're not allowed to use the same names as you see here for your own functions. Like it's not a very good idea because you already have them here, right? And so the Python language will get confused as to should it call your function or the built-in function that it already has. So we're going to go back through code and we're going to write a very simple function uh, just to basically have some idea of how functions work and what they are. For that, I'm just going to keep the name for loops here. And we're going to go down here, add a block of text and type in functions here. And okay. So for defining a function, we are going to type in the keyword def, and we can create any function that we can name our function anything that we want, so long as it's not a building function. So I'm just going to define a function, let's say, and I'm going to call it print string. And so you just put in a custom name, a name that you've defined for yourself, and then you put some parentheses. Now this parentheses indicates that this thing here is a function, right? And we'll also see what we can do with that later on. But now I just want to make a simple function. So this is the simplest function that you can make. And then you put in a colon symbol here, and then you hit enter. And as we've seen this before as well, a tab space is provided for you automatically by Google Colab once you hit enter. If you're using a different editor and it doesn't have this tab space, you have to put in the tab space yourself. And then here you can type in code. You can just write code. So I'm just going to type in some piece of code. So we have used print before. I'm just going to type in print hello, something like this. Now, if you notice, if I run my code now, nothing's going to happen, right? Because I've just defined the function. This is different than just typing in print hello. I have I have written print hello in the body of the print string function that I have. And that's also what this tab space here is for, right? So if we want to basically this, if we want this function to execute, what we have to do is that we have to call this function. And the way that we call that function, I'm going to just hit enter, delete the top space that's provided. And here I'm going to type in print string. I'm going to put it in the parentheses. And now if I compile my code, I'm going to get this function as well. Now, in real world situations, in real life, when you're programming, you often have way more complex, often have to write way more complex functions than just printing a piece of string, right? So you can assume there might be like 20 lines in the code of this function. So it makes it very easier to just reuse that piece of code by putting it in a function and then making a call to that function. Okay, so if there is any questions, just let me know. Also, do this on your systems and um, give me a thumbs up if you feel satisfied with what you have so that we can continue and move on. Now, one of the cool things that we can do with our functions is that we can also provide some data to the function and let the function work with the data that we're providing to. So let's just define another function here. I'll just call this say hello. And here I'm going to just type in, I'm going to give it an argument. I'm going to give the function an argument. And the way that I'll give a function, and that argument is going to be used for when we want to actually call the function, we can call it with our own data that we have. So I'm just going to type in name here, and I'm going to do a slightly more complex example than what we did before. Just going to type in hello here, and I'm going to put in the name right after hello. So if I just now run this function instead of the previous function, here I can provide some data to the function, right? And that function will say hello to, let's say, the name of the person that I provide here. So if I just type in, say hello, Alice, and if I type in, and if I run the function, it's going to run this function for me by the name of Alice, right? So this is pretty cool. Now, if we want to even make this more interesting, what we can do, for example, if you want to combine this with like the stuff that we learned before, I can define a list of names. Um, and we can just go with for loop. I'll just type in for n in names, and I can call the function for all the names, right? So I can just say hello n. going to remove this so that we see. And if I run this piece of code, as you see, I'm going to have, oh, and this is going to, yeah, and we don't need that space there. So as I'm running this function here, it's going to say hello with the names that I have in the list. So this is one of the cool examples that you can also do, and I think it highlights pretty much how a function is useful, right? Now, another cool thing about functions is that you don't have to be the person who writes all your functions, right? You can use functions that other people write to your own advantage. So if we go back to that trigonometry example with sine and cosine values, something like that, there are many, many math libraries in Python that will provide those functions for you. And you can just use that when you want to, let's say, calculate a sine value or um, do any sort of complex math or stuff like that. A lot of AI work, for instance, is processing data and um, basically extracting out some patterns from the data using some statistics or something like that. There are so many functions that are also provided for that you can use. Like you don't have to do all that stuff on your own. Another thing that we can do with functions, oh yeah, thanks for the thumbs up, by the way. Yeah, let's actually get some more of that, and then I can move on. Okay. Yay. Okay. Another cool thing that we can do with functions, let's say I want to define. Okay. Oh, I have a question. Can we replace say hello with something else? So you name the functions yourself, right? So if I change this to, um, I don't know, like let's call it print string two, um, it's fine, but then I'm going to call it, I should use the same name, right? And you can name your functions any name you want, so long as it's not an already built-in function. Um, so the list that you saw, you shouldn't use those names, but any other name than that should be fine. So if I just run this piece of code, it's just going to give me the values that I expected. It's not going to make any change to that. Um, one of the other things that functions can do, which is quite cool, is that they can calculate a certain value for us, and then they can give that value back to us. And by us here, I mean the programmer who's calling the function, right? So, for example, if I want to write a simple function that uh, adds up the numbers of three values and return and gives us the sum, I can do it like this. So I can just define a function sum3, and I'm going to give it a bunch of inputs. I'm going to type in A, B, and C here. So these are the values that are inputted to the function. And here I can calculate the value of A plus B plus C. Now, we want what we want to do basically is in our code here, we want to, let's say, have a value defined some value, and we want to use this function, sum 3, 1, 2, and 3, and then let's say we want to print this sum value. So we can do something like this. We can tell a function to calculate a certain value and give it back to us so that we can store it in a certain variable. Um, and let's say this is the value that we want to calculate. We have a certain keyword that we should use here to get that value, and so that we can able to either store it, print it, do something to it uh, when you're calling the function. Um, and that keyword is return. So if you want to get a plus b plus c as a result of this function, we're going to use return here. And if we now use something like this uh, and store the result in some value, it's going to give us a plus b plus c given the input that we've provided here. So here it's going to give us back or return us the value 1 plus 2 plus 3, which is 6, right? So if I just run this piece of code, as you see, I'm going to get the number 6. Any questions? So I'm going to make this function slightly more complicated, and just through that uh, going basically like reiterating some stuff and elaborating on some stuff a bit more. So let's say instead of sum 3, we want a function that calculates the square of 3 numbers and then adds them all up and return the value for us. So I'm going to just name this function sum 3 squared. And the arguments that I'm going to give here are A and B and C. But what I'm going to do here uh, in the function itself, um, I'm going to type in a value A squared, and I'm going to set that equal to A times A. And I'm going to do the same thing for B and C as well. So this is similar to the previous function that I had, but instead of just adding the 3 numbers, the thing that I want to do with this function, the thing that we want from this function is to get the sum of the numbers squared. So instead of getting a plus b plus c, we want a squared plus b squared plus c squared. Now, when we use return, the function is done executing. So I can't type in more instructions after return. So I can't come in here and say, okay, let's c squared be something else, right? If we compile this code, we're never going to get this line of code. If you're not going, like the Python interpreter is never going to run this line of code. So this is something that you should keep in mind. Never write code after you're done with you return something in the functions, because whenever you call a function, it's going to start from the beginning. It's going to go through the end if there are no return statements. If there are return statements, it's just going to go through that return line. It's not going to go after the return line. So this line is redundant to have here. So just to print this value. By the way, I can do this as well. I can just put this in here instead of putting it in a variable and printing it. I think in the first session someone asked this question as well. And yeah, this is also doable. I'm going to keep it the same as the one above though, just to maintain the consistency of the code. So these two are roughly the same. Okay. Yeah, you can do this on your end. Send me a thumbs up once you're satisfied with your result. And if there are any questions, just let me know. Again, just to reiterate why functions are cool, we can use them a bunch of times, right, with different values. And this is what makes functions interesting, which is like their reusability. So if you imagine if we didn't have functions for all these for these three instructions, we had to do the same thing over and over again. We had to do it 3 times. And now we just have done it 1 time and we're just making a call to that. Okay. So back to the slides. So we basically covered all of this. I'll just go through the slides one more time as to review and to basically formalize what we've learned. Um, so functions can have arguments, as we saw with these couple of examples. So these are arguments to functions. This is an argument to a function. It also can have no arguments, as we saw in this example. Also, functions, as you see here in 2 different examples, in these functions, we don't have any return types. So nothing is being returned in the function. Something is just being done. So by default, what happens is that uh, it's said that this function's return type is void. Void basically means empty, right? So it returns nothing. It returns an empty thing. And functions that have a return type of void usually just carry out a set of instructions. So they do some printing or um, uh, they make some change to data or something like that. If we want to have a value, if we want to receive a value from the function by the end, we should use this return statement. And this return statement, as you saw in these examples here, can be used to, let's say, calculate a mathematical expression and just give that back the result of that to us. Um, And so we have function arguments. When we're calling the function, we use actual numbers or actual input that we want the function to operate on. So here, for instance, I'm providing values 1, 2, 3. I can do something like this as well. So I can do v1 equal 5, v2 equal 6, v3 equal 10, and give the function, instead of just giving it hard-coded number, I can give it variables. So v1, v2, and v3. And if I just run this piece of code, this sum squared values 3 is going to be run with these arguments. So this 161 is the sum squared of is the sum of 5 to the power of 2, 6 to the power of 2, and 10 to the power of 2. And as we saw with this earlier example here, we can give it arguments of any type, right? It doesn't have to be just integers. It can be any type, but the operations that we do on the inputs of the function should make sense to the specific type. So if you're, let's say, if we expect to have strings as arguments of the function, it doesn't make sense to subtract those arguments because a subtract operation is not defined for strings. And finally, functions may return results as we mentioned that as well. So they maintain reusability of the code, and also if you're using someone else's function, for instance, you don't have to know what are the details of that function, right, for using it. So I really like the trigonometry example, so I'm going to go back to that. If you want to know the sine value of a certain angle, we don't have to know how that sine value is being calculated. We can just use a function that someone else has written for us and just use the final value as a result. So this is what we basically covered. For defining a function, you have to specify a name. Depending of whether you need arguments, you need to use arguments in your function or not. You can either not use arguments or use arguments. That's up to you. And we also should define a body for a function. So a function should do something, right? You should write in a piece of code in the function, and you should have at least one line of code, as you see here. And this is also what we've covered. Function stops when we reach return. So it doesn't make sense to continue the function after we have the return keyword. And this is how we write the function. This part, so parameters, the body and the return values. I'm not going to like focus on this slide too much because it's what we've been doing already. And we have a bunch of examples here as well. So, oh yeah, there's one thing that I haven't covered that I will go through. So you might give multiple parameters to the function. You can also specify a default value for a function, as you see here. So as you see, we have parameter to equal 0. Let's actually see this in practice. So this sum3 squared function here, what I'm going to do is what I can do here is I can provide default values for my function arguments. And the way that I provide default values is just like this, right? So I'm setting C in the definition of the function equal to 0. And I can do that with more than one argument, but I have to start from the right and come right before. And So we have something like this. And this is pretty cool because now if I type in something like, just going to use new lines here to separate the outputs. By the way, if you just use print, it's just going to print a new line. So if I just run this piece of code, it's just going to put a line space between the outputs. So here, let's use the same function. I'll just type the value SV1 here, sum3 squared. And now because I have specified some default values, instead of having to give it 3 arguments, I can give less arguments as well. So if I just give in 5 here, this A value is going to be just set to 5. B and C are going to be set to 0. So I can print this value right here. I'm going to get 25. I can do the same for defining the function with 2 arguments here, right? And it's going to, oh, I'm not printing the value, sorry. It's going to give me the sum squared of those 2 values. So because I have a second argument here, despite the fact that B is set to a default value of 0, B is going to be set to 6 because I have that argument in the function. But because I haven't specified anything for C, it's going to have its default value, which is 0. And this can be, by the way, any value that we set it to. It doesn't have to be 0. And this is a pretty similar example as you have here. And this is the return. Oh, yeah, sorry. And I'm going to give you time to uh, basically work on this as well. So I can explain what this function does as well. It does, um, oh, the code that we did. Yes. Um, Let me just maybe do this up here before everything else so that you guys have access to, you can see everything. Yeah, so if there is any question, you can just let me know, Angelina. And are we good, or do we need to do we need to wait on this a bit? Okay, perfect. Yeah, I'll give you guys time to type this down because this is the last content of the slides that I'm covering. I just want to go through the slides so that like we're done with everything and we have some more time. Oh yeah, so functions. So we have a very good question. Does sum 3 need to be defined before sum 3 squared, or they operate independently? They operate independently. So if I rename this, like the name of the functions, so long as they're not exactly the same name, they're completely different things. So if I name this like add 3 numbers, something like this, um, it's going to be different, right? It's not the same as the other function. They completely operate independently. If I just run this piece of code, everything's going to be done as before. Nothing's going to change. Um, And also with function definitions, ordering does not matter. So I can put this in before here, and I can even like comment this function and nothing's going to happen. Like it's I should just probably comment where I'm using the function as well, right? So if I just comment these two pieces of code, they're going to be they're going to be the same. They're not going to be different. Um, so we can also, if I want to maybe organize this code a bit more, I can put them in the different blocks as well, right? So actually, let's do that. So if I just come in up here and add a block of code. So this is the code that we have up here is a different program, right? I can just use all the related functions to that here and just call that on its own, and we can come down here and do a different print statement, and we're going to have this as well. So this is also what we covered. A function might return a value. If it doesn't return a value, it would be of type void. And the keyword that is going to be returning is a specific keyword called none, which is something that we won't get into now. Yeah, and so this is all we're done with the slides. Okay, so now you have time to do this code, or if you have any questions, just let me know. Yeah, and we can, um, and we're almost at the end of the session, so it's, yeah, we have around 10 minutes left till 6:30, around 9 minutes left. So we have some time to basically go through this code as well. Um, I'll teach you something bonus, and I'll end the session if there are no more questions. Um, and let me just bring back the chat here. Yeah. Uh, okay, so you can define variables in one line as well. If like something like this is annoying you, The way that you can do that, you can just type in v1, comma v2, comma v3, and then you can set this equal to the values that you want. So if I want to initialize them with 4, 5, 6, I can just go comma 4, comma 5, comma 6. And if I just run this code, it's going to give me the number that is the result of the sum. So v1 is going to be defined as 4, v2 is going to be defined as 5, and v3 is going to be defined as 6. That's a good question, but yeah. So for there is a difference between giving lists as input and yeah, no, we can't use a list in this case unless we index the list. Um, yeah, because if you give the list as an argument to so yeah, the way that I understand your question, by the way, is that can we instead of uh, doing like giving function arguments as numbers, can we give them lists? Is that a question? Yeah. So you can give lists to function arguments, but you have to change the way your function works to basically like do if you want to, let's say, calculate the sum of numbers in a list, you can do that, but the way that we write the function is different than the way that the way that I'm doing it now, right? So you basically have to go through a for loop in your list and calculate the sums like that. Yes, to the so you have to, yeah, you have to have the have your intentions clear with the code, right? So if your input is of type list, the way that you process the list is different than the way you process just an integer, right? Or 3 integers as function arguments. Um, but yeah, but there are some stuff that we can actually do there, which actually here it can get pretty advanced pretty quickly. But hopefully next time we can cover some of these things. Um, but other than that, yeah, we have to make change to the code. We can't just use the same code that we have for a list. Okay, with that said, I think we're good. Um, unless, oh, sure. I'm trying to get the entire program in my screen. Yeah, this should be good. Okay.
Okay, I think that's it for this session. Thank you, Arya, for your great presentation.